Hello everybody, welcome back to another SAT video. This is from the 2024 Test Bundle 6, Module 2 of the Math section. Let's begin. A right circular cylinder has a volume of 432 cubic centimeters. The area of the base of the cylinder is 24 square centimeters. What is the height in centimeters of the cylinder? Okay, so let's look at the question. Right now they are telling us that this is a right circular cylinder, right? So that means there's a 90-degree angle somewhere, okay? And then it's saying it's a cylinder. Obviously that's very important. They're giving us the volume, right? So V is equal to 432 cubic centimeters. And then this is the base of the cylinder, right? So the bottom or the top, it doesn't really matter. The base of the cylinder is 24 square centimeters, and they're asking us for H, right? They're like, what does H mean? How tall is the cylinder? So now that we know what we need to figure out and the information that was given to us, let's begin this problem, right? So for reference, it's always nice to kind of draw out geometry problems, because this, again, is just a geometry problem. And whenever you have a geometry problem, you just got to instantly pull out your references. That's one thing that I haven't been doing in the video, so I'm going to try and do that as much as possible. But when you have a reference for what the actual uh, volumes and like the formulas are, then you can basically figure out geometry problems a lot easier. So keep this always handy with you for these geometry type problems, right? So let's draw out our problem a little bit. We have a right cylinder. So we have some cylinder. Let's see how good I can draw. Getting pretty nice with it. There we go. And so yeah, we have the cylinder, and we would have the base right there, right? Pretty good. I think I did a pretty good job. And so we have the height, which we don't know. Remember, volume is equal to 432 cubic centimeters, so cm cubed. And then the area of the base, right? We have the area of this base. This, we'll just call this A. A is equal to 24 centimeters squared, or they write it as squared centimeters, but you can say it however you want. So let's look at our diagram and see if there's any more information we can get. So we got the H. Oh yeah, we got the R, right? Radius, can't forget that. So every circle has a radius, meaning the part of the circle or the line that connects the center of the circle to the circumference, right? And area, we have a formula for that too. Okay, so for A and V, we actually have two formulas right on our formula sheet. We know that V is equal to pi r squared h. Do we have h? We don't have h, right? That's what we're solving for, right? We need to solve for h, so we don't know that, but we can maybe figure out r based on a, right? Because if we look, a, the area of a circle, is equal to pi r squared, right? And they gave us the area of the base, right? Which, remember, our base is basically just a circle, and circles have some radius r, right? Oops. So what we can do is, before we start solving, we can make our formulas a lot easier to work with, because then all you have to do is plug in the numbers that you know and solve for the numbers that you don't know using algebra. And in my time as a student, it's always easier to solve formulas using the variables themselves. And it might be a little difficult at first if you're more used to solving stuff like where you have the numbers directly into the equation, but you'll come to learn that when you have the variable you're trying to solve for isolated all by itself, it makes it much easier. So let me show you what I mean. We have a equals pi r squared. That means if we wanted to solve for r, right, because we basically need to figure out what the radius is. Once we know what the radius is, we could figure out what h is, right? So let's figure out what r is using this equation, right? So to solve for r, we divide by pi, right? Divide both sides by pi. That cancels out. We are left with r squared is equal to a over pi, where a is our area, or in other words, r is equal to the square root of a over pi. Okay, so now we know what r is supposed to be. Now we can use the volume equation, right? The volume of a right cylinder, because remember, this is some right cylinder. And we have a right angle that goes from the base here. But I mean, we can just get away with just saying it's a cylinder. Don't really care about the right part, really. So we have our volume equation, right? Is equal to pi r squared h, right? Now you might be wondering, wait, Amar, we have two variables in this equation. We still don't know what r is. Why would we just now isolate for h? Well, we kind of do know what r is, right? We know r is basically the square root of the area divided by pi. And look, we have the area right here. So I mean, you could solve for r right now. You could plug in a, you can plug in 24 divided by pi and put that into your calculator right now, and give a number to r. But usually it's a lot easier, and you'll come to see why, if we just kind of skip that step and just keep it as variables in terms of the variables that we know, right? And then we can plug in the values and solve there, because then you kind of just have to do um, less calculations in the long run, right? Now, before we plug in r into this equation, let's isolate h, right? So h is going to be equal to what? Well, we divide both sides by pi r squared, and then do the same thing here. Pi r squared, that cancels out, and what we're left with is, let me actually write that a little bit lower. H is equal to v over pi r squared. And remember, we know what r is, right? We have this value of r right here. So we're going to plug it in right there and basically have v is equal to root a over pi squared. And this whole term is squared, and is also times pi, right? Which would basically equal, I'm just going to keep on going down. Well, we can simplify it. So square root and the square cancel out. There's a pi in the numerator and a pi in the denominator. So that would simplify to 1. And then we get v over a, right? So then h is equal to v over a. And notice, we don't even need to do any complex math where we would calculate this fraction and then square root it and then store that number. We could just simply use the numbers we were given in the beginning, right? V over a, right? We just have to plug in two numbers and solve. So that to me is a lot easier to do in your calculator than having to do a bunch of steps where you do a square root and then plug it into another formula. So that's kind of the benefit of keeping things as variables and plugging in the numbers at the very end. When you manipulate stuff with variables, you are able to simplify, and then you can only do the operations that are necessary and not have to spend more time fiddling on your calculator, right? And additionally, if you took a very close look at the references, right, you would see that pi r squared is equal to a, and notice that we have h is equal to pi r squared. So you could have also just derived it that way, seeing that, hey, we have a pi r squared in the bottom. We know that this equation, a is equal to pi r squared, and they gave us a. So you could have also done it that way as well. But hopefully, maybe you caught on to that when I first brought this up. So that was just something for you guys to try and figure out while I was doing this. In any case, let's try and solve for h now. So we know that our equation for h is going to be h is equal to v over a. So let me erase that. Where did that come from? Yeah, so now h is going to be equal to v over a, which is, we already wrote that, right? We're going to write it again. So we have 432 centimeters cubed on the top. That's our volume. And then a is 24 centimeters squared. So they also want h in centimeters, right? So notice we have a centimeters cubed on the top and a centimeter squared. Whenever you're dividing by two exponents, it's basically as if you are subtracting the exponents, right? So 3 minus 2 is going to be 1. So that means our answer will be in centimeters, right? Which is what we want, which is good. So again, exponents, if they're two exponents, one on top of the other, you basically subtract the two exponents. So that's our unit down. We got our unit sorted out. That's very important. Always the SAT will try and mess you up on the units, so pay close attention to those, right? And then 432 divided by 24, you can do this in your calculator, but I'm going to try and do it the long division way, just to practice. So we have 432. 24 goes into 43 one time. So do that down here. And then we got to subtract, right? So we borrow 1, that becomes 3. 13 minus 4 is 9. 3 minus 2 is 1. And then this 2 comes all the way down here. So this is a pretty big number. I don't really know my 24 times tables that well, but I do know my 4 times tables. And let's just see, are there any numbers times 4 that give us a 2 at the end? Well, 4 times 8 gives us 32, right? 4 times 8 is 32. So maybe 24 times 8 will give us some number that starts with a 2. Let's try that out. So 24 times 8. 4 times 8, 32, like I did above there. So then 8 times 2 is 16, plus 3 is 9, so we have 192. And yeah, that's our answer, right? So 24 by 8 is 192. And you probably would have gotten this if you did use your calculator, but this is just for those of you that like to do it by hand. So there we go. Our height h is going to be 18 centimeters. Is that one of our answers? Yes, it is. So after all that, we were able to figure it out. So to recap, what I did was first identify the values that they were giving us, right? We figured out that we had a volume and an area initially given to us, and we were dealing with a right cylinder, right? And we needed to find the area H. So we basically took the two formulas that corresponded to the values that we were given. We were given V and we were given A, right? So we looked at our references, looked at V, and then we also looked at A, right? Because the area of a circle, they give us the area of the base, right? The base of a cylinder is basically a circle, right? So we were able to use the area of our circle equation there. And then we rewrote our equation in terms of the values that we knew, right? So, and the values that we didn't know, right? So what we first did was we isolated r, and then we were able to plug in the value of r into our equation of h. Alternatively, we could have just isolated h first, right? Seeing that h has the pi r squared in there. So you also could have done it that way and plugged in this equation and this value for a earlier as well if you made this connection where pi r squared exists in both equations. And then afterwards, after manipulating everything with variables first, we were able to easily do one simple calculation to figure out what h is. So hopefully that makes sense. I'm going to try and just do more explanations where I would try to encourage you and explain to you that the manipulating of multiple equations in terms of variables is much easier than doing so by plugging in numbers in the middle. Again, it just makes it easier to plug into the calculator, makes you less likely to have errors and more likely to get the answer right. So thank you again so much for watching. Let me know if there's any way that I can improve these videos. As always, check out Khan Academy. They have a lot of great explanations and resources for self-studying. And I will catch you on the next one. Thanks.